So, a couple of years ago, Netflix decided to venture into games because apparently a 14-hour true crime documentary was not interactive enough for our audiences. Anyway, so we decided, we're like, let's use our existing analytics platform that we had built for streaming. We were adorable. It wasn't as straightforward. So in this talk, we're going to be talking about some of the challenges in terms of working with game data and how we build a scalable game analytics platform at Netflix. Hello, everyone. My name is Bhargavi, and I'm a data engineer with Netflix Games. Fun fact, I don't play a lot of games, so I have no idea how I got this job. I'm here with Michael, who does play a lot of games, so thankfully one of us is into games. He's a software engineer on the same team. And none of this would have been possible, actually, without the contributions of all of our team members who are not here today, but they're represented by this cute watermelon from one of our popular games called Underwater Melon. So totally using this opportunity to sell this game. Go check it out. So before we dive into the architecture, I know that that's everyone's favorite slide. That's when all the phones come out, but sorry you all, that has to wait a little bit. But before that, I'm going to give a brief overview of games at Netflix and some of the challenges. So Netflix Games today is available on 2 different platforms, mobile and games on TV. So we launched mobile games in 2021 as a new offering on a service. So mobile games run natively on our mobile devices, and many of them can be played offline. So you don't need a constant internet connection. We have more than 100 games on mobile today, and each game is its own application that you can download from the App Store or Play Store. The other category of game is games on TV. So about 2 years after, we launched our games on TV in beta in select regions. So we have about 10 games today, and these are games that you can directly play on your TV or PCs using your phone as a controller. So the game itself runs on remote OpenConnect servers, but your display clients just render the frames. And the whole goal for this category of games is to enable players to play games on multiple device surfaces without the need for high-end hardware like an Xbox or a PlayStation. So now that you have a very good understanding of Netflix games, you might see that the data landscape can get incredibly complex. We have more than 100 games on the platform, and each game is its own piece of software that can behave very differently. We have games across multiple platforms, like I said, TV, mobile, and web, each game running on different game engines, so that can create complexity in the device landscape. We also have multiple game studios that we work with who are building and publishing games across different device categories and device genres, and their data needs are very different from one another. We also have data coming from multiple sources. So we have data coming from your client devices, your phone as a controller, from remote OpenConnect servers, from Netflix services, from game backends. So that's a lot of sources that we need to consider. And I think most importantly, that's going to be the crux of this talk today, is that game mechanics is very different game to game. So if I compare it to streaming, and when I say streaming, it means like movies and the TV shows that you watch on Netflix, the number of user interactions that you can possibly do are quite limited. So you can skip intro, pause, resume, maybe fast forward or exit to go back to the Netflix homepage. But games are so different. There's so many possible interactions that you need to capture inside the game, and this is crucial to understand play engagement. Sometimes this is the kind of nuanced telemetry that's going to make or break a game. And this kind of nuanced telemetry is what we need to solution for. This was the problem that didn't exist on streaming that we had to solve for. So with all that complexity, we needed a robust solution for our game analytics platform that leaned into flexibility and self-service. Because at the end of the day, the game developers will know the best about the game mechanics and the gameplay loop for the individual games. And data teams will never be scaled enough to know about all of the data requests and what's important within the game that drives play engagement. So we essentially have to put the right tools in the hands of the game developers to enable them to start tracking telemetry for their individual games. But obviously, our early days looked a lot different. So the solution obviously didn't happen overnight. It took a couple of years for us to build it out. But we had to start somewhere. So in the early days, we focused a lot more on portfolio telemetry. And when I say portfolio telemetry, these are categories of telemetry that universally apply to all games, like the concept of a game start, a game stop, or play duration. This is also super important and gave us like a lot of good insight into what games are working for Netflix, what games are not working for Netflix, how long people are playing. But at the end of the day, we need to level it up. We need to understand the nuanced interactions and play engagement inside the games. So with that, I'm going to pass it over to Michael to talk a little bit about in-game telemetry or like game-specific telemetry, which is going to be the core of the talk today.
Thank you, Bhargavi. So firstly, I love gaming. It's been a passion of mine for decades, and so much so that last week, my 12-year-old son convinced me to stand in line for 6 hours to get the Switch 2. And it was worth it. Mario Kart World is an amazing game. Nintendo is an amazing game company. But what I'm going to talk about is a game many, many years ago. And this may date me a little bit. Probably a lot of you won't know what the heck that is. But that is a game called Space Quest. And when I was a young kid, this was my favorite game, and probably still is one of my favorite games of all time. I played it multiple times since then. But I want to tell you a little story about me as an 8-year-old kid playing this game and getting stuck trying to figure out how to push that stupid rock onto that spider droid. It took me 3 months to figure it out, and during that time, I did not enjoy the experience I was having. I was frustrated. I was ready to give up. This was my favorite game, and I was ready to throw it away. Now, in-game data, why do we track in-game data? It's for this type of scenario. When are our users frustrated about what they're doing? When are they bored about what they're doing? When is it too hard? When is it too easy? All these questions are really important for a game developer, a game studio, to understand about their game, how to make it better, how to make our members enjoy the experience that they're doing. So it may be a simple scenario, but it kind of speaks to a larger thing. Now, back then, we didn't have kind of the systems in place to do what we do now, but this kind of helped me and informed me in where I was going to go. And we built the Game Analytics platform, which was a tool that was aimed to create the modeling, logging, and analyzing of telemetry, a very seamless experience. So in the example that I gave before, where I was an 8-year-old kid who got stuck in this situation, the ideal situation would be to have some sort of telemetry that would tell the developers, hey, there's a lot of people getting stuck here, maybe we should figure out what that is. Obviously, back in the day, they didn't really have a way to patch it as well. Live service games weren't really a thing, but you kind of get the idea. The other thing that we have to deal with is slightly different to what a lot in this conference is dealing with, and that is compute scaling. We don't really have an issue with compute scaling. Netflix has been doing this for decades. They're very, very good at handling a lot of data. Sometimes it doesn't go perfect, but they handle a lot of data every day. So we don't really have to worry about it. We can rely on all the things that Netflix does well and focus on the things that maybe they haven't really thought about. And this is more human scaling. And what do I mean by that? So as mentioned, we have hundreds of games on our platform. And hundreds of studios that build these games all have different kind of workflows that they deal with, all have different engines that they use for the game, different environments. It's a very different kind of system each and every time. The games that I have up here, these are all Netflix games that have been released recently. Black Mirror Thronglets, which is a really fun game and also a very great tie-in with the TV show. But that's a very different game to Cozy Grove, which is aptly a cozy genre game, which is also different from Squid Game Unleashed, which is more like a mini-game, competitive game. Oxenfree, a narrative game. All these are very different games, and how you log the data is going to be different. So we're dealing with human scaling. Our small team that we have cannot handle that. We can focus in on our big bets, the games that are important to us, but at the end of the day, we can't handle it for everyone. And we wanted to make a system or a platform that would be for everyone. So before we get into the details of that, I want to talk about how we decided to go along that path. And we started to focus on 3 different things, specifically developers, data, and discovery. Now, there's 3 different things. They all focus on different kinds of things, but they all point to the same solution, which is a seamless experience for our end users, of which, as Bhargavi mentioned earlier, there's a diverse set of stakeholders with different requirements of what they want, different kind of use cases that they're looking at, and different things they want out of the platform itself. And without this, it's somewhat impossible to scale. We have to have this kind of self-serve approach, and these North Stars, if you will, point to that approach. So the first thing is developers. So game developers, if you've ever interacted with game developers, they tend to like making games. Makes sense. And logging telemetry isn't high on their list of things they want to do. It's not high on the list of priorities for people. The studios generally, if you've ever kind of been part of the game industry, there's a thing called churn. Sorry, not churn, it's crunch time. Sorry, that's what I was trying to say. There's a thing called crunch time. And that's when everyone is working 80 to 90-hour weeks, and they are just trying to get this game done. And if our analytics team then comes to them and be like, hey, let's put in telemetry, they're like, nope, we can't do that. So the easiest approach is to make sure that it's as easy to integrate into the games as possible. And so we did this a couple ways. There's 2 snippets of code up there. The first snippet is auto-generated code. And so what we do is when our end users model their events, they will create an event that will be, in this case, I actually can't see what that one is, but this is a planet entered event. So in the game Rocket, you have a little rocket and you go to a different planet, and this event is fired when you enter that planet. It's got a couple of properties with it, but the end user, they're going to do this in a nice UI. It's going to be drop downs, buttons, really cool, easy to approach. The code that is generated is then used and dropped directly into their game. So if they're using Unreal or Unity or some custom engine, they can just drop it based on whatever language they have. And we support multiple languages like C++, C#, Java, a whole bunch of different languages. Once the code is dropped in, then it's a one-line logging of telemetry. And usually that's done through our SDK or the web API, but it's a really simple one-liner. And that's kind of the goal, is to make sure that there's just one simple line, one easy thing to do so that they can just get on with their job and just log their data. So we made sure that was a very big focus. And each and every time there's constantly new features, constantly new things that we have to deal with, and we're constantly speaking with game developers, okay, how do we make this easier? How do we make it even simpler to drop in? So that's a constant focus for us. The next thing is data. And obviously, us being an analytics team, data is very important to us. So there's a couple of things that we focused on with data. One is for those events that you saw, that code that was generated, these are strongly typed events. There's no raw JSON that is thrown across the wire and then we have to try to schematize it or deal with unstructured data or something like that. We make sure our events are strongly typed and sent so that we know exactly what it is. And it's schematized throughout. So you'll see on our architecture diagram, our pipeline, from end to end, it's schematized. And that's partly for the analysts and partly for the game developers as well. Throwing raw JSON may seem easy, but that's rife with errors. You can constantly like throw raw JSON and be like, well, that's not what we want. We need to change it to this, and you kind of got this back and forth. If you have a strongly typed event, it's much simpler to kind of make sure that you're getting it right. And it forces that modeling up front, but then it allows for analysts to be able to know exactly what data is going to be there. It's not this big mess of unstructured data that you got to deal with. And this helps us focus on answering the questions that game developers are looking to get answered. The last North Star is discovery. This is a little bit harder and something we haven't quite kind of cracked quite as easily. And what I mean by this is that Netflix has tons of data about viewing habits of people, about the media that is consumed, about the games, about multiple games. And so figuring out how those events map to each other, how people can discover what is actually being tracked, this is kind of a hard problem, but it's something that we're constantly trying to figure out, okay, how do we make it so that when the end user comes to our system, they know what's out there? They don't have to go through a bunch of SQL tables and figure out what the name of some table is, join it to some other table, map it to something else. It's all there simply. Now, like I said, this is a hard problem. We haven't quite cracked it, but it does help us focus when we're creating features, when we're doing things. How does this help our discovery North Star? I've been talking a lot about what our North Star is, but one of the things that we've built is the game event service. And the game event service is part of the analytics platform. It's the UI that everyone kind of sees when they come in. It's where they model the data. It's where they download the code packages. It's a way to help people build this telemetry and not get bogged down into the details of things. So I'm going to focus on a couple of features. The Games Event Service has a lot of features, but these are the 4 primary things that you can think of in that there's event modeling, code generation, integration, and automation. So event modeling is kind of an easy. You have an event, and how do you model that event? And in the past, sometimes people have created YAML-style events or code-based events, or they build pipelines to do that kind of stuff. What we've done is created an event that is stored in a relational database, and then that can be easily used to generate code from. So we have the modeled events, and then code is generated from that model event in whatever language we have. Once we have that code generated, it can be easily downloaded for a game developer. They can just drop it into their engine or their environment, and then they can start using it like they would a library or an API or something like that. So the integration part, as I've mentioned earlier, is supposed to be really nice and simple, nice and easy. Then the last piece, which I won't speak too much about here, is the automation piece. And that is the idea that everything that we do is automated in the background. We don't want to have to, as a team, figure out how to create pipelines or build it for certain events. So pipelines are automated and automatically built. Dashboards are automatically built. Everything at a very base layer is automatically done for us so that we don't have to go in and do it for our end users. And this is a really key and important part of that piece. The Games Event Service you can think of as something that pulls in a lot of other pieces together and kind of abstracts away the complexity of it. Because again, I know all of you are probably really smart data analysts and data engineers, and your job is to do a lot of this stuff. Our end user's job is not to do a lot of stuff, and exposing them to those things is not going to be beneficial to anybody. So the workflow that we deal with is pretty simple, and that's, again, the idea. You model the event, and that can be as simple as that planet-entered event with just a couple of fields. I can't remember specifically what those fields were in that case, but I think there was a string there and maybe an integer and just a couple properties with a couple things that are passed along. Like I said, once you've modeled those events, the developers will download the code package, drop it into their game, and then log. End to end, from modeling to logging, this should take about 5 minutes. The longest part of doing this is actually the generation of the pipelines. And that's only because it just takes a little bit of time to spin up some of the pipelines in the background. But in terms of modeling, in terms of actually logging, I've done it a couple times where I've taken one of our studio's games and I've been like, okay, well, I want to see how quickly I can go from A to Z. And roughly speaking, if I'm not thinking about it too much, 5 minutes is kind of how it does. And that's kind of the goal, make it really super easy. And then the dashboards, there's kind of two variations of dashboards. There's automatic dashboards that are simplistic in nature. And they're supposed to be simplistic in nature. They're not supposed to be overly complex. And then there's the more complex dashboards. And the complex dashboards are not automatically generated. We give the end users the ability to do what they want. So whether that is using Superset or Tableau or various other tools, whether it's using raw SQL, whether it's kind of plugging into our Kafka topics or our pipelines in general, we allow for a more complex kind of hook into our system, but we also want to kind of cover that 80%, the most use cases when people can self-serve what they're doing. And that's the goal, and I kind of repeat this over and over again. The idea is that this is simple, and it's supposed to be as easy as possible. So this is the slide that most people have been waiting for. I've noticed in multiple sessions that everyone gets out their phones, and I see a couple phones going up, and they're like, this is the Netflix architecture. It is a very high-level view of our architecture. It is not diving too deep into things, so just understand that I'm kind of taking a very high-level picture of this. But what I'm going to cover, and I'm going to let Bhargavi do kind of the end piece, I'm going to cover up to the edge logging, and then I'm going to let Bhargavi take over and do from the Flink routing job there, and she'll explain all those pieces. But again, I'm kind of going to reiterate some of the things we're saying. So you see the Games Analytics platform, which is a bit of a misnomer because that would actually be the Games event service. The events are modeled, stored in a relational database. On demand, a user will then request code for that or for multiple events, so it'll get in a nice package that you can just drop into your game. Then there's two variations of how to log. Games generally have a game client and a game server. Not always, but most of the time they have both of those. Some games will only have a game client, but in general you can say that most of them have client and server. Now a lot of games will log the telemetry directly from the client. Some games will just do it from the server. It just depends. Each game on Netflix is integrated with the Netflix SDK. It does a bunch of things, but the thing that I want to kind of point out is the telemetry piece of it. So there's an API within the Netflix SDK that is a telemetry API, which has a function called log event. And any events that you model in the game's event service and that code package you download, you can just pass that object into the log event API, and it will hit through our servers. And that's literally all you have to do. Granted, you have to integrate the Netflix SDK into your game, but once that's done, and that has to be done anyway, logging the events are simple. For the game server, it's a little bit different. That has to go over HTTP to a web API. There's obviously security involved in that, which it's not necessary for this talk to get into. But essentially, it's a similar process. Some of our generated code will do it for you, but there are some instances where we just can't feasibly do it. And that's usually the case where there's no standard HTTP libraries that can be used. So for Unreal, there is a standard library that's in Unreal, and we can plug into that standard library. For C++, if any of you are C++ programmers, there is not. And HTTP libraries can be frustrating in C++ in general, and so we kind of just leave it up to the user and how they want to do it. Once it gets there, it logs to the Netflix Edge servers, which at that point is handed off to the Flink routing job. And I will give it over to Bhargavi to explain the rest.
Thank you, Michael. So once the events get through to the Netflix ecosystem via the edge logging layer, they get processed by our central real-time Flink application, which does a majority of the data transformations, like extracting the relevant keys, enrichment with useful dimensions and other metadata. But one of the primary responsibilities of this Flink application is to dynamically route all these events into dedicated Kafka topics. So now we're heavily using Kafka and Flink as our real-time data processing tools. So we maintain a dedicated Kafka topic per event on the game's event service, which means if we have 20 different titles, each instrumenting 20 different events, we're talking about 400 different Kafka topics. So once the data lands in Kafka, it gets synced to Iceberg and Druid, which is our persistent data storage layers. Iceberg is a central data warehouse backed by S3. And in this case, the schema of each Iceberg table matches the schema of the Kafka topic. So they're always in parity. And I'm going to go through some of the individual components a little bit later. But once the data lands in these primary Iceberg tables, we obviously have a lot of reporting tools which are internal, but also Superset, Tableau, which lets you access the data directly under the hood. Druid is a complementary technology which provides low latency real-time analytics and is complementary to Iceberg, depending on the use cases that you have. So the goal of it is this entire process is automated end-to-end. So there is zero incremental data engineering when there's like a new event created or there's a new title that's onboarded. And let's go through the data components that we had to build to enable the solution to work. So the first one was adopting an infrastructure as code solution. Like I mentioned in the earlier slides, we're looking at hundreds and thousands of artifacts, hundreds and thousands of Kafka topics, Iceberg tables, Druid tables, and it's just not scalable for any data engineer and go and create these artifacts manually. And just to take a step back, Netflix has a homegrown real-time data platform called Data Mesh, which is a fully managed streaming data movement and processing product. Prior to games, it was pretty much like a drag and drop interface where data engineers or data practitioners can go and create their artifacts like your sources, your sinks, create the pipeline, so that data engineers can really focus on the things that can drive business value, like the actual data transformation layer without having to manage the streaming infrastructure. But even with this drag and drop interface, it's not scalable for any one person to keep going and create these pipelines for every single event. So we had to advocate for infrastructure as code capabilities within our data platform to enable us to spin up infrastructure on the fly every time there's like a new event that's created. So the way it works is every time a game onboards onto the game's event service and creates an event, it kicks off a YAML-based automation flow that goes and calls a bunch of APIs and spins up all of these sources and sinks. And one caveat is once the event is in production, we don't allow for breaking changes. So if the game developer wants to go and create, make any breaking changes, it's essentially a new event, so you have to deprecate the old one. But if they do end up creating non-breaking changes, the schema propagates to all of the artifacts that are created. Okay, so let's move on to the next component. So the second major component that I want to talk about is a primary Flink application that processes all of the guest events and routes it to these automatically created Kafka topics. So we have a central Netflix schema management system that's maintained. It's called the multi-subject schema store. It's part of Netflix's schema management system, which is used to handle data schemas for various subjects or data topics. So in order for the Flink app to dynamically route it to the individual Kafka topic, you need two things. So one is the name of the output sink and the most recent arrow schema of that sink. So we maintain unique naming conventions for all of our artifacts. So for GAP, every artifact is prefixed with GAP, then you have the title name, and then you have the name of the event. So because of these strict naming conventions, it's easy for us to generate a unique identifier for every Kafka topic. So the schema ID here is the unique identifier for every individual Kafka topic that we compute on the fly based on the message attributes. So based on the payload that's being processed, we know exactly what title is generating that event and what the name of the event is. And once we have that information, we're able to serialize the information, create a generic record, and pass it downstream to individual Kafka topics. So the third component that I'd like to talk about is the actual analytics layer for enabling consumers to access and run queries from the data that they've generated. So we actually evaluated a lot of tools, external and internal. We wanted a pretty UI that's drag and drop, very intuitive for game developers to work with. Because Tableau is not intuitive, right? I think what we really want to do is scale data teams. And we found Superset had the right feature sets for us and for the game developers to run self-service analytics on the data that they're generating. As part of the games event service, we also automate a lot of the dashboards, by the way. So by virtue of being on the games event service, you can access a lot of the automated dashboards that the game analytics platform creates. But you can always go into Superset. The game developers know exactly where the data is. They know where the tables are. And they can just connect and get going. You can create very simple charts like the one that I have on the slide, or based on how data savvy you want to be about your analytics, you can also create a bunch of nuanced analytics. And the whole goal is to make it extremely simple for game developers to come and run analytics on the data in a self-service format. OK, so moving on to design trade-offs. Obviously, there were a lot of architectural decisions that we had to take along the way. I think one of the mostly debated ones were, hey, should we maintain one single iceberg table versus multiple tables per title? So this category of telemetry, game developers just care about data about their game. So we need to maintain some separation of concerns. There's no point of combining all the data into a single table. So obviously, we want to break it down by title for sure. But then even once we break it down by title, the decision we took is to have one table per event that we create. And the reason is because with the single table approach, we're still talking about complex types, because every event has a different data model. And then it's the same problem all over again. Game developers have to extract the relevant keys. They need to, it's cumbersome to run analytics on complex types. And the other reason is that, or the other approach is to have super wide iceberg tables. I don't think there's any imposed limits on the number of columns that you can have. But I mean, let's say title instruments are lots and lots of telemetry. We're looking at super wide iceberg tables, and it can have performance implications in terms of data scanning and I/O. And it's just it's not simple to understand. There's just so many nulls in the table. It's not intuitive. And the data automation really works well. So we went with a multi-table approach. The second thing is, and a lot of data engineers will find this funny, is we went with a partitioning, processing time partitioning scheme. You must be wondering, hey, we always partition by the event occurrence time in our final tables. But this was a conscious decision that we took, because here we're talking about so many moving parts, so many different iceberg tables. If there are data issues, it's just so much easier to reprocess data that's been partitioned by your processing time. And we just, at the end of the day, keep it simple. I think this is where we need to understand a lot of the user query patterns. And when we talk to the game developers, a lot of the analytics around, hey, have you performed an action or not, versus, hey, when exactly did you perform that action? And the table itself is a very small subset of the data that the game is producing. So you don't run into the risk of super large scan times. And the last limitation I'd like to call out is the superset limitation. Of course, it's not the perfect tool. In fact, creating second order measures like aggregate of aggregates or average of averages, it's still cumbersome, it's not intuitive. But like Michael mentioned, the goal is not to solve for 100% of the use cases. We want to get to a place where game developers have the right tools in their hands that they can run with. And for some of the more advanced analytics, our team will still be involved. So we're still very early in the process. We're obviously trying to iterate and improve our systems. But yeah, this is where we are at. OK, so with that, I'll pass back to Michael to talk about some of the lessons learned.
So I'm going to go quickly over this because we're kind of short on time. And this is the last slide, so it's not going to be much longer. But we learned many lessons over this period, and I'm just kind of pointing out three. And so the first one, keeping it simple. This is something that I've learned over my career in general, but especially here, the idea is you don't want complexity in your system, especially for these kind of users. They want to be able to use it very easily. They don't want to have complex SQL queries that they got to write. They don't want to have to do complex joins on tables. They don't want to try to figure out where their data is, or they don't want to try and figure out how to integrate into their game. They want a simple process from end to end. And that was the goal. And so every single time we look at new features, every single time we look at new things to do, it's like, can we make it simpler? Can we make this process simple? Are we thinking about this in a too complex way? Is the solution that we're doing too complex? And so we kind of keep this in mind as we're going. And I think this is good for just about anything in engineering. The next thing is something I didn't quite think about at first, but it kind of cropped up in one of the games that we worked with. And that was the idea of making it easy to see the data. And I've kind of hinted on this throughout the talk. But the idea is we built this system, and then we dropped it into Iceberg table, and then someone could access it through SQL or whatever. And it was like, well, we're done. Now they can do what they want to do. But as it turned out that we weren't done. Because a lot of people are like, where's my data now? I don't want to do what you guys do. I just want to see it. And it's a simple request at the end of the day. But it's something that sometimes we miss in terms of oh yeah, they just want to see a dashboard. They just want to see a report. They just want to see a chart. They want to see the data. There's a sense of satisfaction that when you log the data and then there's a chart that shows the data showing up, there's an immediate gratification that happens when you see that. If you delay it and put in this whole thing of well, you got to write this whole SQL query, or you got to do this, or you got to do this and this and this, it kind of deflates a lot of it. So make it really easy to see it. At least address those early 50, 60, 70% use cases. The last one I'll point out is know your users. So we mentioned this a couple times as well. We have a very diverse stakeholder group. There are game developers, data analysts, data engineers, game producers, game studios, execs, just so many different kinds of people that want to see the data, that want to use the system in different ways. And understanding your audience is very important. If we had built a system that was focused on data analysts, the game developers might have been like, well, I'm not really using this, I'm going to do what I'm going to do. And then no one would have really used the system. So you have to understand both sides. And they may be conflicting, but it's important to understand those conflicts, figure out the best kind of pathway forward. So understanding your users, I think, is a really super important thing. With that, those are the primary lessons that we have learned. I want to thank you, everyone, for spending, 40 minutes or so. So thank you very much.